So the next question, find prime implicant. Find prime implicant, essential prime implicant, and write the minimal expression. So here is a question, f of a, b, c, d is equal to summation 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. So corresponding binary numbers has been written here, 0. These are the decimal numbers. So 0 indicates 0, 0, 0, 1, 2, 4, whatever is there in the question, the same thing will be written here in the binary numbers. So the next step, as you all know, as I have discussed in the last class, first group will be your without ones, that is 0. Then single ones. After writing this one, put a line. Okay. Then single ones, that is 1, 2, 4 and 8. Okay. So put a line, that becomes one group. Next, two ones, that is 5, 6, 9, 12. So here it is 1 and here it is 1. So it is 2 ones. Here also it is 2 ones. In the same way, we'll go for 3 ones. So 13 and 14. As we don't have 15 in the question, that is 4 ones will not be having here. So again, next step is what? We will compare this group with this adjacent group, this group with this adjacent group, this group and with this adjacent group. So 0, I'll compare it with 1. So when I am comparing it 1, you have to remember that it should vary with only one single position. Okay. So when I can compare 0 and 1. Why? Because it is varying with one single position. So what can I write? It is written as 0, 0, 0. Which one is varying? There I'll put a dash. So 0, 0 dash. In the same way 0, 2. So 0, 0 dash 0. In the same way 0 and 4, 0 dash 0, 0. 0 and 8 dash 0, 0, 0. Because here it is 0 and here it is 1. So only this first position is varying. So I'll be writing 0 dash 0, 0, 0. So now next I'll compare this group. Okay. With complete this group. That is 1, I'll compare it with 5, I'll compare it with 6, 9 and 12. And I'll see if it is varying with one single position, then I will write down that one. If not, I'll not write that. So whichever is being compared, you have to put a tick mark over there as it has been put here. Okay. So 1 and 5 can be compared. Yes. So it, where it is varying at that position, I'll put a dash. So it is 0 dash 0, 1. In the same way, 1 and 6 can be compared? No, because it is varying with two positions. See here, it is 0, 0, 1, whereas 6 will be 0, 1, 1, 0. So it is varying with two positions, so I cannot take 1 and 6. So 1 and 9 I can take. It is written as dash 0, 0, 1. 2 and 6 I can write. If I put 0 here, it becomes 2. If I put 1 here, it becomes 6. So 2 and 6. In the same way, 4 and 5, 4 and 6, 4 and 12, 8 and 9, 8 and 12. Okay. 4 is compared with 5, 4 is compared with 6. 4 and 9 cannot be compared as it is varying more than one variable. 4 and 12. At least once it should be compared. Okay, at least once it should be compared. So next 5 and 13 I'll see. Can it be compared? 0, 1, 0, 1. Here it is 1, 1, 0, 1. So only the first position is varying. So I'll be writing dash 1, 0, 1. And 5 and 14 can be no, because more than one position it is varying. So I cannot compare 5 and 14. In the same way, I'll see for 6 and 13 can be compared. No, why? Because it is varying more than one position. I cannot compare 6 and 13. In the same way, I'll see for 6 and 14. 6 and 14, can it be compared? Yes, only the first position is varying, that is dash 1, 1, 0. So I'll be writing 6, 14. Okay, 9 and 13 can be compared. Yes, it can be compared. It is 1 dash 0, 1. 9 and 14 can be compared. No, it cannot be compared. Why? Because it is varying more than one single position. So 12 and 13 can be compared. It can be compared. So it is 1, 1, 0 dash. See here, it is 1100. Here it is 1101. So only one, the last position is varying. So I can write 110 dash. So 12 and 14 can be compared. Yes, it can be compared. It is 11 dash 0. 11 dash 0. Okay. So now again I'll compare this group with this group. Okay. Then this group elements, that is this group elements, I'll be comparing with this group elements. So 0, 1, 4, 5. I'll see what I have told. When you are comparing, the dash should be at the same position and it should vary with one single variable. Okay. So where it is 0, 1, at the last it is dash. So where it is, here it is. Okay, here it is. So it is here it is and here it is. So 0, 1, 4, 5 can be compared and it should be vary with the dash should be at the same position. First thing. And the second condition is it should again vary with the one position, one variable. So 0, 1 is what? It is 0, 0, 0 dash. So 0, 0, 0 dash it is. So what here it is 0, 1, 0 dash. So here it is varying. So I can write 0 dash 0 dash. So it is 0 dash 0 dash. Okay. In the same way 0, 1, 8, 9. So 0, 1, 8, 9 what it is? Dash 0, 0 dash. In the same way again I'll see for 0, 2. 0, 2 at the third position it is dash. So where is the third position here? It is here. Okay. So there what it is 0, 0 dash 0. Here what it is 0, 1 dash 0. So at the second position it is varying. So it is 0 dash dash 0. So 0, 2, 4, 6 is 0 dash dash 0. Okay. Next still anywhere it is at the third position dash? No, it is nowhere. Next 0, 4 where it is at the second position there is a dash. So where it is second position it is here. 0 dash 0 dash again it is 0 dash. Okay. See here 0, 4, 1, 5. So what you'll be getting 0 dash 0 dash. Writing 0, 4, 1, 5 and 0, 1, 4, 5 it is one and the same as we have already written. So put a tick mark over there. Got 0, 4. When I compare it 1, 5 what you'll be getting 0 dash 0 dash. The same thing what we have already written. So put only a tick mark over there. Next 0, 4 still anywhere it is second position. Okay, here it is 0, 4, 8, 12. So 0, 4, 8, 12 when you are seeing 0, 4 is 0 dash 0, 0. 8, 12 is C 0, 4 only. Okay, 8, 12 is 1 dash 0, 0. So which is varying? It is the first position is varying. Dash dash 0, 0. Understood? Any doubts? Girls, any doubts?
No, ma'am.
Everyone is understanding or shall I write and show you all? Fine. So 0, 4, 8, 12 is written. In the same way 0, 8 when I compare 0, 8 and 4, 12 again you will get the same thing. So I only put a tick mark. Okay, I'll only put a tick mark. So now all the group elements of this group is being compared. Fine. So now I'll go for 1, 5 with this group. The group elements of this one I'll compare with the group elements of this one. So 1, 5 when I'm saying, okay, this group is complete. So I'll put a line over here. Okay. So now 1, 5. 1, 5 at the second position there is a dash. So see where it is second position. This one is the second position. This one is the second position. So what you'll be getting 1, 5, 9, 13. It is dash dash 0, 1. So dash dash 0, 1. You see only 1, 5. What it is 0 dash 0, 1. What is 5, 13? Sorry, what is 9, 13? It is 1 dash 0, 1. So only one position, that is the first position is varying. So what I will write dash dash 0, 1. Okay. So next I'll see for 1, 9. So 1, 9 and 5, 13. So same thing what I have written now. 1, 9, 5, 13 and 1, 5, 9, 13. You will get the same thing, that is dash dash 0, 1. So what I will do, I'll put a tick mark 1, 9 as well as 5, 13 also I'll put a tick mark. Next 2, 6. 2, 6 at the second position, where it is? Here it is. Can it be compared? 2, 6, 9, 13. No, why? Because it is varying more than one position. I cannot compare 2, 6 and 9, 13. Okay, though it is at the second position only dash, I cannot take. Why? Because it is varying more than one position. Okay, still anywhere else? No. Then next what it is? 4, 5. 4, 5 where it is? It is at the last position. So 4, 5 what will I do? 12, 13 I'll see. So why? Because at the last position it is dash. Here also it is at the last position, it is dash. 4, 5 is what? 0, 1, 0. 12, 13 is what? 4, 5, 12, 13. So 1, 1, 0 dash. So the first position is varying. So what I'll do? Dash 1, 0 dash. So dash 1, 0 dash. So 4, 5, 12, 13 is also same thing. And next 4, 12, 5, 13 also you'll get the same thing. So there also you put a tick mark. Next what I will do? 4, 6. 4, 6 at the third position. Where it is? 4, 6 it is here at the third position. 4, 6 what it is? 0, 1 dash 0. 0, 1 dash 0. 4, 6. 12, 13 what it is? 1, 1, 0 dash. So what I'll be getting? I'll be getting dash 1 dash 0. In the same way, 4, 12 as I've already discussed. So 8, 9, it is at the last position. Here it is the last position. So what it is? 8, 9 is 1, 0, 0 dash. 12, 13 is what? 1, 1, 0 dash. So what it is? 1 dash 0 dash. So 1 dash 0 dash like this. Understood? So one more step here is you can compare this group with again this group. This step was not there in the previous problems. Okay, this group can be compared with this group. The condition is the dashes should be at the same position and again it should vary with one single variable. Okay, so see this dash dash, that is at the second position, and at the fourth position it is dash dash. Anywhere there it is second and last position you are having? No, you are not having. Now 0189, okay, 0189 45 12 13. Whether it is that, okay, 0189 first and last position, here also first and last position. Again it is varying with one single variable, that is the second position only is varying. So what can I write? Dash dash 0 dash. See here. So what I have written? 0189, okay, 4 5 12 13. Here it is 0 1 4 5 8 9 12 13. 0 1 4 5, here it is 8 9 12 13 also the dash and dash second and last position. So what can we write? Dash dash 0 dash. So 0 1 4 5 0 1 8 9 4 5 12 13 8 9 12 13, put a tick mark. Okay, dash dash 0 dash should be getting. Next, what is remaining? It is 0 2 4 6. Next, what it is? 4 6 12 14. So write down those things: 0 2 4 6 4 6 12 14. So what is corresponding? It is C bar, it is A bar, D bar, it is B, D bar. So now I'll write down the prime implicant table. Okay, so while writing the prime implicant table, 0, I'll write down these things, this one and this one. So I'll write all the questions what is there given here. So wherever is a cross mark, wherever is a number, I'll put a cross mark over there. And I'll check whether which one is having single cross mark in the column. Okay, so I'll round off that one. And that corresponding will become your essential prime implicant. That corresponding will become your essential prime implicant. So that will be written in your expression. So here all the three are the essential prime implicant. So everything will come under your minimal expression. Understood? Any doubts?
No, ma'am.
No, ma'am.
Next one. F of ABCD is equal to summation 1, 3, 4, 5, 7, 8, 9, 11, 15. Okay, so same procedure. Write down the numbers. Okay, write down if it is without ones, one group, with single ones, one group, with two ones, one group, with three ones, one group, and four ones, one group. So I'll start comparing. Okay, when I compare, it is 1 and 3, 1 and 5, 1 and 9, 4, 5, 8, 9. Always put a tick mark. Otherwise, cross check it whether it is there. So 1 is there, 4 is there, 8 is there, 3 is there, 5 is also there, 9 is also there. Okay, 7 is there, 11 is there, and 15 is there. So all are there. Okay, fine. So now what I will do, I'll compare the group elements of this with group elements of this and this group elements with this. So now when I start comparing, what I should see first condition is I should see the dash. So 1, 3, where it is 0, 0, dash 1 at the third position, where it is at the third position. You cannot compare the group elements with the same group. Okay, you have to compare it with the adjacent group. So here it is dash here at the third position. So where it is here. So, and it is varying the second condition, it should vary with one single position. So you compare 1, 3, it is 0, 0, dash 1. So here it is 0, 1, dash 1. So which one is varying? The second position is varying. So what I'll be writing? 0, dash, dash 1. So I've written 1, 3, 5, 7. Once again, I'll tell 1, 5, 3, 7. Again, it will be the same thing. 1, 5, 3, 7. As you have written already. 1, 3, 5, 7, 1, 5, 3, 7. It is one and the same thing. So I'll put a tick mark for 1, 5 as well as 3, 7. And I've put a tick mark for 1, 3 as well as 5, 7. Okay. Next. So 1, 3 still where it can be compared? It can compare with 9, 11. So 1, 3, 9, 11. Again, what you'll be getting? Dash 0, dash 1. Okay. So 1, 3, 9, 11 is same as well as 1, 9, 3, 11 is also same thing. So I'll put a tick mark over there. Okay. So next, 4, 5 can be compared? No, because at the last we don't have anywhere dash. 8, 9 cannot be compared. Okay. You cannot compare the same group elements. That you all should remember. 4, 5 and 8, 9 cannot be compared. Okay. Next, as it is not been compared, I will not put a tick mark over here, these two. So next, 3, 7, I will compare it with 3, 7, 11, 15 can be compared. So it is dash, dash, 1, 1. So 3, 7, 11, 15 put a tick mark. And also it is same thing, 3, 11, 7, 15 is also the same thing. I'll put a tick mark. Then 5, 7, 5, 7 can be compared. Here with this, no. 9, 11, no. But once it is compared here, you have already put a tick mark, no need of worrying. So here you can see these two have not been compared. Okay. So what it is, you can, if you want to check whether it is correct or no, you can see that this 4 is not written anywhere here, as well as 8 is not written, whereas 5 and 9 are there, but 4 and 8 are not there. So you have to include these things in your prime implicant table. So next thing is, and again if you can compare it with the adjacent group, what we have done in the previous problem. But that cannot be compared. Why? Because dash and dash here it is at the second and third position, whereas it is not here. Here it is first and third position, whereas it is first and second position. Comparing it with the previous problem, that 8 cell grouping is not possible. There it was 8 cell. This is only the 4 cell. 1, 2, 3, 4. Okay. In the previous problem, how it was? It was 8 cell. Okay. So it cannot be done. So we will go for the next step. It is prime implicant table. If it is possible, then you have to compare again. If it is not possible, you have to leave it. You have to go for the prime implicant table. So when I'm going for prime implicant table, I have written like this, all these three things with these two, which has not been compared or not been written. So what I'll be doing, 4, 5, 8, 9, and I'll write all. I'll put a cross mark. I'll write down the questions what has been given, and I'll put the cross mark wherever it is. So that is 1, 3, 5, 7. I'll put it 1, 3, 5, 7. I'll put a cross mark. So 1, 3, 9, 11. I'll put a cross mark 1, 3, 9, and 11. So next 3, 7, 11, 15. I'll put a cross mark 3, 7, 11 and 15. Rest all I will not be putting a cross mark. Next 4, 5 at the cell number 4 and at the cell number 5. 8, 9 again at 8 and 9. So whichever is a single cross mark in the column, that is cell number 4 and cell number 8. So this becomes your essential prime implicant. As well as 15 is also your essential prime implicant. I'll put these three things should be there in your it should be there in your minimal expression. So what it is? One more term is missing here. Okay. So 8, 9 is what? It is A, B bar, C bar. Because this is A, this is B bar, this is C bar. Here it is A bar, B, C bar, 4 and 5. Okay. In the same way, this also is written, it is A bar, it is D. 0 means bar, B bar, D. This is C, D. So correspondingly, what is 4, 5? It is A bar, B, C bar. What is 8, 9? It is A, B bar, C bar. And what is 3, 7, 11, 15? It is C, D. So if I take this element, so if I leave this one, I cannot leave. Why? Because cell number 1 is not covered in these 3. Okay. So I have to take 3 is covered here, 5 is covered here, 7 is covered here. Okay, 3 is covered here, 9 is covered here, 11 is covered here. 1 is not covered in these 3 where you have taken for minimal expression. So any one I have to take. Either this one I have to take or either this one I have to take. Because if I take this one, if I am leaving this one, 1, 3, 5, 7 is what? It is plus plus 1, 3, 5, 7 is what? A bar D. A bar, I'll put D like this, I'll put A bar. Okay, it is A bar D. So I've taken A bar D over here. I can leave this one. Why? Because 1 is covered here, 3 is also covered here, 9 is covered here, 11 is covered here. So I can take this one. Or you can also write CD plus A bar B C bar plus A B bar C bar plus which one we have left? 1, 3, 9, 11, that is B bar D. B bar D. Like this, it can also be written. Okay. So the next problem 1, 5, 7, 8, 9, 10, 11, 13, 15. I'll give that as your assignment. Let us go for the another question. So that is don't care terms. Okay. So now f of a, b, c, d is equal to summation 7, 9, 12, 13, 14, 15 plus summation d. D indicates it is a don't care term, that is 4 and 11. So when it is don't care term, next what you have to do is you have to write the problem f of a, b, c, d is equal to summation 4 together, join this one 4, 7, 9, 11, 12, 13, 14, 15. I will write And I will indicate always that it is a don't care term. That is 4 and 11 by putting a star over there. Okay. By putting a star over there, I'll indicate that it is a don't care term. The procedure remains the same thing again. You have to put without ones, with single one, with two ones. Okay. With three ones, you have to write. So here it is one single one with two ones. Okay. Then with three ones, then with four ones. So now I'll compare this group elements with this group elements with these group elements, this group elements with this group element. So 4 and 12, I'll be writing dash 1 0 0. Okay. 4 and 9 cannot be compared, so it is not written. Next 9 and, so this group is finished, so I'll put a line over there. Next I'll compare 9 with 7, 9 with 11, 9 with 13, 9 with 14. Again 12 with 7, 12 with 11, 12 with 13, 12 with 14. Satisfying the condition. Okay. That means what is the condition? That it should vary with one single position. Only then I'll be writing it. So which can be compared? 9 and 7 cannot be compared. So 9 and 11 can be compared. So I'll put a star if it is a don't care term. So what it is written? 1 0 dash 1. Put a tick mark if it is compared. Put a tick mark. In the same way 9 and 13, 12 and 13, 12 and 14. Okay. So this group element has been completed. So I'll put a line over there. So next 7 and 15, 11 and 15, 13 and 15, 14 and 15 has been compared. So I'll put it is completed. So now I'll compare 4 and 4, 12 with this one. That is at the first position there is a dash. Whether it is there, it is not there. So it has not been compared. I'll put, okay, it has not been compared. So don't put a tick mark over here. So next I'll go for 9, 11. 9, 11 dash is at the third position. Where it is here. So 9, 11, 13, 15, I'll write it as nothing but 1 dash dash 1. 9, 11, okay, 13, 15. In the same way, 9, 13, 11, 15 is also the same thing. When you compare it, put a tick mark over there. 9, 11, 13, 15 is also same thing. 9, 13, 11, 15 is also same thing. So put a tick mark over there. Next. 12, 13 at the last position it is. At the last position it is. So only the third position is varying. So what will be getting? 1, 1 dash dash. So I have written 1, 1 dash dash. Next. Still anything at the third position? 12, 14, 13, 15 is also same thing. Put a tick mark there for 12, 14 as well as 13, 15. It is same thing. So now it is compared, complete finished. So which one has not been compared? If you want, you can see. Don't go for don't care terms. Don't see whether the don't care terms is there or no. Our main intention is which one is not compared? 4, 12 is not compared. So I'll write 4, 12 over here. Dash 1, 0, 0. 7 and 15 has not been compared. It is dash 1, 1, 1. So write the prime implicant table. 9, 11, 13, 15. 12, 13, 14, 15. 4 and 12, 7 and 15. So put the cross marks and see for the single cross mark. Okay, when you are seeing for the single cross mark, where it is? It is here, here and here. So which one is your essential prime implicant? 9, 11 and this one and this one. So what it is you'll be getting? This is AD. Okay, this is AD. 12, 13, 14, 15, what it is? It is AB. See here, it is AB. 1, 1 it is. So AB. 4 and 12, what it is? 4 and 12 is not an essential prime implicant. Why? Because 4 is your don't care term. Okay. 4 is the don't care term. So you need not see for 4. 12, it is already compared here. It is already there. So we can neglect this one. Okay. And while putting, you shouldn't put the don't care here. Okay. In the question what they have given, don't care terms are 4 and 11. So 4 and 11 is not there here in your prime implicant table. Remember that. Okay, in the question they have given the don't care term as 4 and 11. In the prime implicant table, you shouldn't put 4 and 11. Okay, so whatever is the main question, you have to put that. So you have put and AD plus AB plus this is what BCD. So BCD. We have neglected this one. Why? Because 4 is the don't care term and 12 is already covered here. So it can be neglected. It should be neglected. So what is the minimal expression? It is AD plus AB plus BCD. So this is f of a, b, c, d is equal to pi 0, 2, 3, 4, 5, 12, 13 plus pi d 8, 10. First thing is you take this as f bar. Okay, f bar, I'll put a complete complement I will do. So m0, m2, m3, m4. I've taken 8, 10 here and I've indicated that as don't care terms. So complement both the sides. F bar is equal to summation, F bar is equal to complement of that is bar m0, m2, m2, m0, m2, m3, m4, m5, all those things. Then when you remove the bar, it is m0, this is capital M. Why? Because it is max terms. Pi means max term. So when you remove the bar, it is plus with small m, m0, m2, m3. This about F bar we'll see at the last when you write down the solution. What is the procedure of writing down the solution? When you get question like this, that is pi, when you get what is the procedure. So in the same way we will do summation 0, 2, 3, 4, 5, 8, 10, 12, 13. So same thing as we have done in the previous problem, the same way you will follow. Okay. So this step also you know, this step also you know, and this step also you know. Okay. So now when you are writing in the prime implicant table, you have written, okay, and you have got the, what is the question? Find prime implicant. Okay, they have told to write down the prime implicants. So you have written here. So F bar of ABCD is what? It is B bar, D bar. It is C bar, D bar. It is B, C bar. It is A bar, B bar, C. So all are prime implicants, whereas these two are essential prime implicants. That will be considered only when you are writing the expression. What they have told you have to write all the prime implicants. So all the possible groupings should be written. So now this is F bar of ABCD is equal to B bar, D bar, C bar, D bar, B, C bar, A bar, B bar, C. So now if I remove this bar, F of A, B, C, D, how can I write? It is B plus D, it is C plus D, it is, if suppose bar, I will bar it, F bar or double bar and this one bar, for example. So this becomes, when I remove the bar, it becomes B double bar plus D double bar. So what it will be? B plus D. So in opposite I am telling, in the same way directly I am telling, it is C plus D, it is B bar plus C, it is A plus B plus C bar. So that is what F of A, B, C, D. Understood? Any doubts regarding this problem?
No, ma'am.
No, ma'am.
Next question, find the minimal cover for the prime implicant table shown below. So this is the prime implicant table, what they have shown. So R1, R2, R3, R4, R5, R6 and R7. And these are the cross mark what they have given. Okay. So now you need to compare these columns. Okay, you need to compare. So when you you have to reduce this prime implicant table. How will you reduce it? So now compare C2 and C1. If C2 is dominating C1, okay, when C2 is dominating C1, you can delete. Dominating in the sense, the cross mark what C2 is having, the same cross mark the C1 should also have, but more. Okay. So now compare C2 and C1. C2 and C1. Which one is having more cross mark? That is C2 is having. And it should be at the same position what C1 is having. So what we can tell, C2 is dominating C1. So delete C2. I'll put a tick mark. Delete C2. In the same way, delete C3 as C3 is dominating C7. See, at the first position it is having, at the fifth row it is having, plus C3 is having more. So C3 is dominating C7. So I will delete that one. I'll put a tick mark. In the same way, you have to check for all the columns. C5, delete C5 as C5 is dominating C7. same positions it is having and it is more. So delete C5. In the same way, delete C6. Okay. Compare it with C1. It is having at the same position and it is more. So delete C6. So after deleting, what is remaining? C1, C4 and C7 is remaining. So in columns, which one is dominating, we will delete. Whereas in row, which one is dominated, that we will delete. So now C1, C4, C7. So now delete R5. Okay. As R5 is equal to R1 and the cost also should is more. When you delete, the cost should be more. Okay. So R5 is equal to R1. Yes or no? R5 is equal to R1. Why? Because only at C7 R1 is having, only at C7 R5 is having. And this cost is more. So we will delete R5. In the same way, delete R6. As R6 is equal to R4 and the cost of R6 is more. So I will delete R6. In the same way, delete R7 as R7 is equal to R2 and the cost of R7 is more. So I will delete this one. So after deleting, what is remaining? R1, R2 and R4 is remaining. So R1, R2, R4 like this. R1, R2 and R4 is remaining. It is single cross mark. So everything like all becomes your essential prime implicant. So minimal expression will be R1 plus R2 plus R4. Okay. So I'll continue in the next class.